This is Ben Elliott's ENME351 Lab 2. So in the statement delay, microseconds 2000, the 2000 stands for 2000 microseconds or 0.002 seconds. Analog write can write at essentially continuous values between 0 and 5 volts, while digital write can only write at discrete 0 or 5 volts. Analog write doesn't truly write continuously, but rather turns on and off 0 or 5 volts very quickly to give the impression of continuous voltages. In the image of the Arduino, the pins 3, 5, 6, 9, 10, and 11 can be used for analog write, or all the ones with the tilde, and pins A0 through A5 and digital 0 through digital 13 can all be used for digital writing. The analog write function is on a scale of 0 to 255, and Arduino's PWM frequency is 500 Hertz. So in the blink, if we upload that, you will see the LED blinking on and off. It's very straightforward. So next, for the blink faster, we added our own delay length thing. So say if you add that at 50 milliseconds, it will blink considerably faster. And I found the delay length of around 20 milliseconds is where you can clearly start to see the LED turn on and off. And this makes sense because this would be a frequency of 50 Hertz or 50 frames per second roughly, and 60 frame per second video. It looks very clean and smooth. So now going to fade. Whoops, that's not the original one because I modified it to go faster. But if we go to the original one, we can see it fading on and off, on and off. And then here the brightness variable, only if you change that, it only changes the brightness that it starts at, but changing the fade amount will change the rate that it goes on and off. Next, going for the manual fade. So first you can see I created essentially my own analog write function, but using the digital write thing and creating a runtime timer, which is just a fraction of the 2000 microseconds that the period of the pulse width modulation is, and then it just leaves off the balance of the time. And then we implemented that into a fade function similar to the example fade, except I did my own way. And yep, so here you can see, so this is at the fastest speed and with the fastest blink speed. So it goes up, blinks 4 times, goes down, blinks 4 times. And then using the fade rate variable, we can change this to go a little slower. Using the B time or blink time, we can make that a little slower as well. So if we go here, upload it, you can see it now goes at a more moderate speed and blinks at a slower rate. And then we can make that even slower. So if we drop this down to a 2, I think it was, yeah, 2 is nice and slow. And pump this up to a 200, that's 2000, oops. Upload. Now you can see it will blink even slower and go up and down even slower. May have made it a little too slow, run out of time, but it will blink 1, 2, 3, 4, and then go back up. So for my individual problem, I essentially made a binary counter, which is visually represented with the LEDs. So it's this LED being 0 or 2 to the 0, and this one being 2 to the 4th. So it can count up to any number from 0 to 31. So say we put in 31, it'll show it counting up. So it starts at 1 and then 2 and then the 3 with both of them, and up it goes until all of them are lit, signaling that it's at 31. Or if we try another number, say 15, actually let's do 17. It will mark here and it'll count up until just the 2 to the 4th, or the 16, and the 2 to the 0, or the 1, is lit, making 16 plus 1 is 17, the number we're counting to.